Okay, so compared to the absolute value function, we can do the same kind of blueprint that we did with absolute values, right? But this time, instead of with absolute value signs, you're going to start with an x squared, because that's the parent function, x squared, and that's when you get the u, right? The parabola. This is will be all this graphing. We had the line, we had the v, and now it's going to be all u's, okay? So if I start with x squared, you can kind of make the same assumptions. If I add or subtract in the parentheses, not the absolute value, in the parentheses, that's going to mean left or right. Adding, I'm going to the left. Subtraction, I'm going to the right. Good. If I'm adding, subtracting outside the parentheses, that means very good. Up is adding, subtraction is down. And then we're only going to do vertical stretches and compressions. And the reason we only do vertical stretches and compressions is because absolute value, like I told you, are like jail bars. Nothing goes in, nothing comes out. You can't distribute stuff into absolute value. When you have parentheses with a quadratic, you can. So you can really turn any horizontal into a vertical. So that's why we only look at the vertical stretches and compressions. You won't have that crazy 1 over b thing this time. And then, of course, the reflection, which would be a negative out here, and that would be reflect over the x. Okay. Why don't we reflect over the y? What happens to the u if I reflect over the y-axis? It's the same thing, right? Okay. So we're only worrying about those 4 things. So just like we just got done doing with absolute value, we're going to describe, right? We're going to describe the transformations and then graph. Okay? And I'm going to teach you the shortcut of graphing. We're going to use our graphing calculators. But then there's also a faster way, and I'm going to teach you that too. Okay? So let's describe, let's show some examples. And I know this copied weird. On my copy, the graphs stayed, but for some reason when I sent them for copies, the graphs for the 3rd row are on the next page, and I apologize for that. I am not sure why that happened, but you're just going to have to deal. All right, so if I look at this first example, what are my transformations? Up 4, very good. Right 3, very good, right 3, okay? So if I went right 3, up 4, and what do we know about the parent function? Parent function's at 0, 0, and it's making a U shape. So if I went right 3, up 4, where's my vertex? Where's my vertex at? If I went right 3, up 4? 3, 4, very good. So I can start there, 1, 2, 3, 1, 2, 3, 4. My vertex is right there. Okay. Now, if there is no horizontal stretch or compression, you can graph this just mental math. Okay. If there is stretches or compressions, you'll probably want to grab a graphing calculator. Or you can grab a graphing calculator no matter what, that's fine. But the quick way is called the 135. Have you guys done that before, maybe back in Algebra 1? Okay, so it's not a constant slope because it's curving, right? So you just can't go up 1 over 1 like you did the absolute value. You go like this. You go up 1 over 1 both ways, and then you go up 3 over 1. And that's usually enough, but the next one would be up 5 over 1. So you go like this, up 1 over 1, up 3 over 1, and then up 5 over 1 would be your last one if you had room for it. It's called the 135. And that only works if there was no horizontal stretch or compressions.
So you go up 3 over 1 over.
Okay, and then you connect your dots. So let's try another one. Okay, so what are my transformations here?
Left 4, down.
Very good. Left 4, down 5. Okay, so where's my vertex? If I went left 4, down 5, where's my vertex? Negative 4, 5. Very good. So I know negative 4, 1, 2, 3, 4, 5. And since, right, there is no stretch or compression, I can do the 1, 3, 5. So from that vertex, I go up 1 over 1, put a point, And then from that point, go up 3 over 1, and then go up 5 over 1. And the same thing on the other side. You go up 1 over 1, up 3 over 1, up 5 over 1. Is everyone understanding that, the 1, 3, 5? And you probably wouldn't have to do the 5, right? If you just did up 1 over 1, up 3 over 1, that's probably enough to graph a parabola. So what about this one? What are my transformations here? Very good. This negatives always mean reflect. So reflect over the x. And then what's that? Up 5. Very good. So I did not move left and right, but I did move up 5. 1, 2, 3, 4, 5. Okay. You can still do the 1, 3, 5 rule, but it's going to open down because it reflected over the x-axis. Okay, so in this case, you're going to have to go down 1 over 1, down 3 over 1, down 5 over 1, right? Because it reflected. So don't forget, when you have reflection, it's going to open down. Oh, and what was my vertex for this? If I only moved up 5, what would be 0, 5? 0, 5. Okay. Maybe let's skip and do one with a stretch or compression. I think we're getting it. Sometimes I have too many examples because I just don't know how fast we're going to get it. Okay, so what's going to happen here? 3 things, right? Negatives always mean reflection. So that negative means reflect over the x. The half means, very good, vertical compression. And the -7, right 7. Good. Okay. So no, I know right 7, so what's my vertex? Right 7, 0. Because I went right 7. Okay. But now I can't do the 1, 3, 5 rule because I have this compression, right? So everything got cut in half. And that's trickier to do mental math. So what I would do is I would get out the graphing calculator and plug that in. Okay, so again, y equals, and how do you put that into a graphing calculator? You'd go negative, parenthesis, 1 divided by 2, or you could do negative 0.5, that's fine. Squared, and you have a squared button, it's the 5th one down on the left side. So you could either go caret 2, or there is just a squared button, so it's a little bit faster. Your preference though, what you want to use. And that's it, and I would graph it. Oh, I forgot the x. Oh my gosh, whoops. Did anybody notice that and they just didn't say anything? I forgot the x minus 7. I was too worried about the squared. So negative half, right? X minus 7 squared. And then I should get a parabola. There we go. There's my parabola. So I can see that the vertex is 7, 0. So that's right. But it's opening down. So I would go second table. And again, you're going to want to find symmetry, just like the absolute value. So what? 3, negative 8, 5, negative 2, 7, 0. There's my vertex. 9, negative 2. And that's probably all I can fit. So 3, negative 8. 5, negative 2. 7, 0. 9, negative 2. So if we do let's move on to the 5x squared. Okay. So where's my vertex? And how did I move? What does the 5 mean?
Up 5.
No?
No.
Up 5 would be plus 5.
Vertical stretch of 5.
Vertical stretch of 5. And that's it. Vertical stretch of 5. that means my parabola got really skinny. It got stretched up. Okay, where's my vertex going to be then? 0, 0. I did not move left and right, up and down, so it stays 0, 0. I can pull out my handy dandy graphing calculator and just put in y equals 5x squared. So clear that out, 5x squared, just like that. And there's probably only going to be maybe a couple points to graph. You'd want x is 0 because that's where your vertex is. Yeah, see how there's only 3 points to graph? Because a stretch of 5 will blow that up really fast. So I only have these 3 points to graph. -1, 5, 0, 0, and 1, 5. Okay. What else? Maybe one more with all of the transformations. We haven't done one of those. One more. And you could probably use the graph above it, right? If I do this one right here, you guys can use the graph above it, right? Because we didn't do that one. Or did we do that one? Oh yeah, we did. You should have an open graph though to use, right?
On the next page.
We'll do one more. We'll do this one, the -3x + 7 squared - 8, just because they'll have all of the transformations together. Okay. So what are my transformations? Very good. Reflect x, vertical stretch of 3, left 7, down 8. Good. So where's my vertex? If I went left 7, down 8, where's my vertex? -7, -8. So I know I can go left 7, down 8. The 1, 3, 5 rule, I can't do that because there was a stretch. So I would put it in the graphing calculator, and it also reflected, so this is going to kind of go off my graph a little bit. What do you guys get for points? So -3 x + 7 squared -8. Okay, so see how you're barely gonna see this one because it reflected and it moved way over. So what? You probably need -7. These will probably be the only points you can use. -8, -11, -7, -8, -6, -11. Right? It's going to be off.